Hello everyone, in this video I am going to explain you about minimum spanning tree and Kruskal's algorithm. Before going to the Kruskal's algorithm, let us know what is meant by minimum spanning tree. It is a spanning tree of a connected, weighted and directed graph that connects all the vertices with minimum possible total edge weight, which means that it should have a weight associated with each and every edge. It should be undirected and also connected. Let us see what are the properties of minimum spanning tree. First property is it connects all the vertices. For example, in the initial graph, if it has 5 vertices or 8 vertices, in the final minimum spanning tree, it should also have 5 vertices or 8 vertices. The second property is it should not consist of any cycle. There should not be any loop. Third property is it has exactly b minus 1 edges, where b is the number of vertices. For example, we have total number of 6 vertices in the initial graph. Then in the minimum spanning tree, it should have 6 minus 1, which is equal to 5. 5 edges should be there. And the fourth property is the sum of 8 weights is minimum among all the possible spanning trees. So from the graph, we can construct n number of possible minimum spanning trees. Out of this, we have to consider which is giving the least weight. Let us see the point 3 and 1. For example, I have 4 vertices A, B, C and D. So 4 vertices are there and 4 edges are available in this initial graph. I can construct a minimum spanning tree where A, B, let us assume this is the minimum spanning tree. If you observe here, how many vertices are there? Initially 4 vertices are there. So 4 vertices. How many edges? 4 edges are available. This is the let us assume this is the final minimum spanning tree. How many vertices are there here? Vertices are 4. Initially 4 vertices. Here also 4 vertices. So the first criteria satisfied. And then the second point, they should not form a cycle. What is a cycle? If I close here, if I consider this edge also, it will form a closed loop. Okay. This should not be considered. This is a cycle. It should be eliminated. And there is no cycle. And what's the third point? It should have exactly b minus 1 edges. How many vertices are there here? 4. So 4 is the total number of vertices. So how many edges are there here? 1, 2 and 3. So 4 minus 1, which is equal to 3. So total number of edges are equal to 3, which is equal to b minus 1. So this condition is satisfied. So all the properties of the minimum spanning tree have satisfied. So we can conclude that this is a minimum spanning tree. Let us go to Kruskal's algorithm now. So it is one of the example of minimum spanning tree. Kruskal's algorithm, let us assume one graph. So how many vertices are available here? 1. So 1, 2, 3, 4, 5, 6. Total number of vertices are 6. Total number of edges. Total number of edges are 1, 2, 3, 4, 5, 6, 7, 8. So initially I have 8 edges. So 9. It should be 9 edges. Now the first step in the Kruskal's algorithm is we have to write. This is the first step. We have to draw a table and arrange all the edges according to the cost, ascending order of the cost value. So here I have written total number of edges are 9. So each and every edge is associated with some cost. 1 to 4, it has cost 1. 1 to 2h, it has cost 2. And 4 to 2, similarly 4 to 2, the cost associated with it is 3. And 3 to 2, the cost is 3. Similarly, 3 to 6, 8. And 2 to 6, 7. The same thing I have written here in the form of a table. So now, I have written the cost of each and every edge in ascending order. Now the first step is we have to consider the least cost edge. What is the least cost edge here? 1 to 4. Let us draw 1 to 4 here. So where is the edge? 1 to 4. So I am drawing 1 and here vertex 4. Now connect these two vertices with an edge. What is the cost associated with it? It is 1. So I am writing 1. What is the second one? 1 to 2. What is the cost here? 2. So where is 1 to 2? So here I have 1 to 2. So I am drawing 1 to 2. The cost is 2. And what is the third one? 4 to 2, which is 3. Where is 4 to 2? If I take 4 to 2, it will form a loop. Am I right? So it should not form a cycle. So I am avoiding that. It should not form a cycle. So I am avoiding the third one. And go to the fourth one. What is the fourth edge? 3 to 2. The weight is 3. So 3 to 2. Draw here. 3 to 2. What is the cost associated with it? 3. And now, go to the fifth edge is 5 to 1. If I draw 5 to 1, is there any cycle? No. So I can consider it. So I am drawing 5 and 1. What is the cost here? 4. And go to the side, next one, 4 to 3. 4 to 3, what is the weight associated with it? 5. So let us see whether it is forming a cycle or not. If I draw 5 to 3, it will form a cycle. So it should not be considered. I am eliminating 5 to 3. Okay. So next, what is the next one? 4 to 3. Next, 2 to 6. Where is 2 to 6? 2 to 6, if I draw a cycle, if I draw an edge from 2 to 6, will it form a cycle? No. It is not forming a cycle, so I can consider it. Now, let us go to the 8th one, 3 to 6. What is the weight associated with it? It is 8. So now, let us see whether it will form a cycle or not. 3 to 6. 3 to 6, if I draw 3 to 6 here, it will form a cycle. Am I right? According to the properties of minimum spanning tree, it should not form a cycle. So, I am eliminating it. So, I am removing this. And go to the next one, last one, 5 to 4. What is the weight associated with it? 9. So, 5 to 4. 5 to 4. If I draw 5 to 4, it will form a cycle. Am I right? So, it is violating the property of minimum spanning tree. So, I am not considering it. Now, I have covered all the edges. So, this is the final minimum spanning tree. Let us see whether it has satisfied the criteria, the properties of minimum spanning tree or not. What is the first criteria of minimum spanning tree? It should not form a cycle. So, there is no cycle. No cycle. So, first criteria satisfied. And what is the second criteria? It should have all the vertices. How many vertices are there here? total initially 6 vertices. So finally whether we have all the 6 vertices or not, 1, 2, 3, 4, 5, 6. So total number of vertices are 6. So I can write vertices are 6. So second condition satisfied. What is the third condition? What is the third property? Total number of edges. Total number of edges are equal to p minus 1. So 6 minus 1, which is equal to 5. So 1, 2, 3, 4, 5. So this condition is also satisfied. And now let us go to the fourth property. We should have the minimum cost. What is the total cost here? Let us calculate the total cost. Total cost equal to weight associated with each and every edge. So 4 plus 1 plus 2 plus 3 plus this is 7. So 7 which is equal to 17. This is the total cost. Let us calculate the initial cost here. What is the total cost? So 9 plus 4 plus 1 plus 5 plus 3 plus 2 plus 3 plus 8 plus 7, which is equal to 42. Which is equal to 42. This is the initial cost. Now we have reduced the total cost to 17. So this is our minimum spanning tree. This is about the Kruskal's algorithm. Thank you.